Hi, in this video, we are going to see the area of regions bounded by a line and a curve. So here's an example. So you have a curve which is y equals to 2 set of x intersect the line of y equals to x at the point of 4 and 4. So find the area of the shaded region bounded by the curve and the line. So as we mentioned and you have learned in the previous topic, okay, to find the area under the curve, okay, so you first need to have the equation of the curve. As such, in this case, you have y equals to 2 set of x. If you integrate, okay, with the limits given, for example, here it is 0 until 4, okay, if you integrate this particular equation, 2 set of x dx, you will be able to get the area under the curve from 0 to 4, which means that you're getting the area of this whole particular part. Alright, similar things is if you have the equation of the other line, okay, in this case, which is y equivalent to x, sorry, this is 0, and then this particular point is 4. Alright, so if you integrate this particular equation, okay, this is area number 1 just now, okay, and this is area number 2 equals to, alright, so from 0 to 4 x dx, you will be able to get the area which is under the straight line. So now the area of the shaded region is the area in between the curve and also the straight line. So all you need to do is, okay, you take the bigger portion, okay, which is A1, okay, minus the smaller portion, which is A2, to get the area in between them. So the area of the shaded region will be equivalent to, you take A1 minus A2. As you can see here, okay, it's already solved for you, where the first step is I actually find the area under the curve, which I refers to A1 here. Area of the triangle, okay, either you integrate, put the limits in, or you can use area of the triangle formula, where half times with base times with height, because the base is given, which is 4, the height is given as well, which is 4. So you can get the area also by using the simple formula of triangle, that is for A2, okay, and then integrate, put in all the values, okay, get the correct integral, substitute, and you will be able to get the answer. Okay, that is for area under the curve, in between the curve and also the line. Also, there is an alternative method to find the area of the shaded region, okay, using other method, but then same example. Alright, just now I have mentioned, if you realize, okay, we always take, okay, the area which is having a bigger portion, okay, so which in this case, if you can see, the part which has a bigger portion will be the part at the top line, okay, so fx. So most of the time, okay, you will get the area, okay, in between the curve and the line, or two curves, okay, by taking the top line, okay, minus the bottom line, okay, minus the bottom line. So since the limits are the same, we can also write it as a to b limits fx minus gx and then dx. Okay, you can combine the two equations, okay, because the limits are the same, and then simplify it before you do integration. Okay, if you look at the example again, okay, the same example that we are going to use, but this time with a different approach. Okay, so now let's see which one is the top line. So obviously this line actually appear above the second line, which is y equals to x. So to find the area of the shaded region, first you integrate from 0 to 4 to z of x dx minus, okay, 0 to 4 x dx. Okay, so now both limits are the same, so we can combine them and put it as integration of 0, 4 to z of x minus x dx. So now you can start your integration, where this is 2x to the power of 1 over 2 plus 1, so you will get 3 over 2 divided by 3 over 2 minus x squared over 2, close bracket, put the limits from 0 to 4. Simplify the equation. You will be getting 4 over 3, x to the power of 3 over 2 minus x squared over 2. Okay, so now substitute the limits in the equation. So you first have 4 over 3, put 4 to the power of 3 over 2 minus 4 to the power of 2 over 2, and then continue with substitution of 0, which will give you the whole thing as 0. And then lastly, put all the values in your calculator. You should be able to get the answer as 8 over 3 square units for area. Alright.